from HB1. So my name is Aida. This is Hafizudin. This is Dalila. This is Alia, Mariam, Shazwana, and Paris. Okay. Today we will discuss about this molecule and this molecule. So the first one is 3-methyl cyclopentanol. So we will name this molecule. The carbon which attached to hydroxyl group will be the first carbon, and this will be the third carbon. So this is okay, and this molecule cyclopentene 1,3-diol. So this is the first carbon and this is the third carbon. So this is cyclopentene 1,3-diol. Okay, so
next we are going to discuss about how many chiral carbon is in these two molecules. So for the first one is 3-methyl cyclopentanol. There is 2 chiral carbon, which is here and here, 2. And for the second one is also have 2, 1 and 2 chiral carbon. So what's that mean by chiral carbon is a carbon that attached to 4 different atom or group. Okay, that's all. Next.
Alright, move on to our next discussion, which is we have to determine how many isomers are there in each molecule. So the first molecule, we know that there is 2 chiral carbon. Therefore, from the formula 2 to the power of 2, we have 4 isomers for this particular molecule. Alright, then move on to the next one. This one, we have 2 chiral carbon. Therefore, using the formula, based on the formula, we also have 4 molecules. However, this molecule have a plane of symmetry right over here. Therefore, we have to subtract 1 molecule because this is a meso compound. Therefore, we have 3 molecules of isomer.
Okay, for molecule 3-methyl cyclopentanol, as Dalila said, we have 4 stereoisomers. First, so this one is cis 3-methyl cyclopentanol. So the enantiomers
This is the mirror image of this molecule. When we rotate this molecule 180 degrees, it does not give the same molecule. Therefore, this is the mirror image is non-superimposable of each other. Next.
for trans 3-methyl cyclopentanol, also the enantiomers, the stereoisomers, the mirror image is not superimposable because if we rotate this molecule at 180 degrees, the stereoisomers we get are not identical. It's not identical to this molecule. For 1,3 cyclopentane 1,3-diol, we have only 3 stereoisomers because these molecules has chiral carbon, but it has plane of symmetry. So one stereoisomers for this molecule, it does not have enantiomers, because if we rotate this molecule, the mirror image is identical to this molecule. But for the trans cyclopentane 1,3-diol, we have its stereoisomers, which is enantiomer, because if we rotate this molecule 180 degrees, it's not identical to this stereoisomers. Alright, now for the next question, we have to draw the 3D notation of all the stereoisomers. Okay, for the first molecule, which is 3-methyl cyclopentanol, we have 4 stereoisomers. For the first two, this is the cis stereoisomers. And next, the 3 and 4 compound is the trans stereoisomer. Alright, the relationship between the first and second compound is the enantiomer, which means it's a mirror image to each other. And next is 3 and 4 is also an enantiomer, because 3 and 4 is the mirror image of each other. But for the relationship between 1 and 3 and 1 and 4 is diastereomers, because it is not a mirror image for each other. That's all for 3-methyl cyclopentanol.
So we have to draw a 3D molecule of cyclopentane 1,3-diol. For cyclopentane 1,3-diol, we have 3 stereoisomers. First stereoisomers is this. We only have one, because this molecule has plane of symmetry. So it is a meso compound. For second and third molecule, it is enantiomers, because it is mirror image, and 1 and 2 are diastereomers, because it is isomers but it is non-mirror image, and 1 and 3 also diastereomers.
And now we're going to look at the plane of symmetry. So in order to find the plane of symmetry, we have to divide the molecules into 2 even halves, and we have to fold it. If the 2 halves match, then it has a plane of symmetry. So out of all these compounds, only one compound has plane of symmetry, which is the cyclopentane 1,3-diol. If we split it into 2 even halves, and then we fold it, the OH and this OH will match. But for the other compounds, it won't match. Okay, so this one.
Okay, and as a conclusion, for 3-methyl cyclopentanol, it has 2 chiral carbon. So, in order for us to find the stereoisomer for this molecule, we need to use the formula 2 with the power of n. And for n is 2 chiral carbon. So 2 with the power of 2, we got 4. And then this is a chiral compound, and because of there is no plane of symmetry. And the second one, we got cyclopentane 1,2-diol. It has plane of symmetry. Thus, we have to minus with 1. For 2 chiral carbon, 2 with power of 2, and then we have to minus with 1, we'll get 3 total of stereoisomers. And this is also, this is a chiral compound because of the plane of symmetry. I think that is all from our group. Thank you.